Okay, so let's talk about significant figures and rounding, and Professor Bullough told you about this in the third analysis session for MBB 165, so I'm not going to talk too long about it, but basically significant figures means the informative digits in a number, and I'll give you some examples to show what I mean. And it does not count, in general, leading zeros, or trailing zeros. So e.g., if we've got the number 0.002, then all this, we call that leading zeros, and if we got, let's say, 2000, then these guys, we call them trailing zeros. So each of these numbers has one significant figure, so only the 2 is actually telling us something useful about the number. Excuse me. So let me give you some examples, because that's how I like to work. So if we've got the number 53, say, that's got 2 significant figures, 5 and 3. But likewise, if we've got 0.0053, for instance, also 2 significant figures. Let's say if we've got 53,000, then also 2 significant figures. Okay, so these are trailing zeros and leading zeros, and we don't count them. Apart from if we're to add, at the end here of our 53,000, if we were to add a decimal place, that means that we really mean it. So that means it really is exactly 53,000. We haven't rounded it, we haven't estimated it. So now this number has 1, 2, 3, 4, 5 significant figures. And another thing is, if we've got a 0 after the decimal place, again, that means we really mean it. So that we really do mean that that we've measured that properly, it hasn't been rounded, so that would be 6 significant figures. Yeah, so that's an important rule. So that decimal point means we really mean it, that it is exactly 53,000. Because the point of significant figures is to say, so we don't want to make any claims that we can't back up. If our measurement is not very precise, then we don't want to be quoting some very precise numbers that we've been given, that we've got out of our calculations, for example. So if we've got these enormous numbers of molecules that we're doing our molarity calculations of, we don't know that it's exactly 2,300,021.5 molecules, right? So, yes, we can't really back that up, so we have to do rounding and use a sensible number of significant figures. And I'm going to tell you a couple of rules in the next video about how to do that, but I don't want you to get too hung up on it. I just want you to realise that sometimes it's not appropriate to put down all the different digits that you get out of your calculator when you're doing these sums. That's my real point. Okay, so now rounding. So let's see. So our general rule, so this is what Professor Bullough told you to do. Let's follow his way. So if you've got a 5 at the end, round up. If it's an odd number behind, or round down if it's an even number behind. So that's Prof. Bullough's rules. Let's do that. So for example, if we've got 235 and we're rounding that, we want to round to get rid of this last significant figure, that would be 240, but also if we got 245, that would give us 240, because this is an odd number, this is an even number. So shall I give you an example? So for example, let's say if we want to round 53,243 to 4 significant figures. So what's 4 significant figures? That's 1, 2, 3, 4. And then so we have to get rid of this last digit. What's that? So we have to round down. It's less than 5. So that's 53,240. I haven't put a decimal point at the end because, you know, to take account of the amount of doubt we have about this last digit. How about if we want to do it to 2 significant figures? So that's these first two, the 53,000. So that would give us 53. This is smaller than 5. So rounding, we're not rounding up. This isn't really rounding down, is it? That's let's say don't round up. Leave it as it is. That's what I meant. Okay, so don't use too many significant figures if you don't really mean it, if you aren't really confident in that precision of your measurements, and then we can have rounding to a certain number of significant figures and using this rule of Professor Bullows.